Hello everyone, welcome to the first online video lecture on analog electronics circuits. This course is meant for third semester diploma electronics and communication engineering students. As a part of this endeavor, in our today's discussion, we are going to discuss DC regulated power supply under the first unit called power supplies. Okay, before getting into the core topic discussions, let's briefly discuss about the importance of analog electronics circuits in the field of electronics and communication engineering. Well, when we think of just like that, a question may arise in our minds that when the world is heading towards digital or a digital world, we call today as everything is digital, such as digital television, digital music systems, in the medical field or any other field, automobile field. If any field we take, everything is being getting digitized. Hence, we call the world as a whole as a digital world. Then a question definitely arises, yet why we still need to study analog electronics and their related circuitries, isn't it? Okay. The answer for this question lies here. Without analog electronics, we cannot have digital world, as it needs analog interfaces to communicate computer to computer or cell phone to cell phone, or we take any digital system examples. In almost all digital setups, it needs analog interfaces or analog inputs. Because when we talk about any digital gadgets, they all need data or informations which are analog in nature, because the world around us is analog. That is analog in nature. That means when we take any signals or what we can sense, all the signals what we can sense are nothing but continuously varying physical quantities, such as it may be a sound signals or voice signals, that you can feel that my voice or my sound is not a constant or fixed, or it is not constant at all the instances. So it is continuously varying with respect to time. Not only the sound signals, we find numerous types of physical quantities, such as temperature, pressures, humidity, images, motion pictures. Many are there. So all these are called as a time varying signals, because they vary continuously with respect to time. As these signals are first captured by a sensors. So it means these signals are first to be sensed by a sensor circuitry. Then the sensors, the signal which is captured by sensors will be very small in amplitude. It needs to be amplified by a analog circuitries. Then some noises may be incorporated in it. We need to remove those noise quantities, noise signals. By the again, we for this we need to depend on analog circuitries, and to be processed to get the desired shape or desired output. Again, for that also we need to make use of the analog circuitries. Then in order to improvise it to the further level for accuracy or fine tuning, or up to the mark or the best quality, what we say is can be we are able to get that best quality after passing through the digital systems or a digital circuitry. Hence, we can say that analog and digital go hand in hand. Hence, in one shot, we can say that uh, without analog electronics, there is no digital world existing. So, both goes complement one another. Okay. Now, with this, hope you all have able to understand why we need analog electronics circuitry, why we need to study the analog electronic principles, working of their circuitries, types of various analog circuitries. Okay. With this, let's move on to our prime objective of today's discussion, that is DC regulated power supply. Power supplies. Okay. Let's first understand what is power supply and why we need it. Okay. Then we'll move on to the DC regulated power supply. Okay, power supplies are nothing but an electrical device that supplies electric power to an electrical or electrical or electronic loads. The primary function of the power supply is nothing but to deliver the correct electric current, voltage and frequency to power the load. Hence, what is power supply? Power supply is a device or a setup or a equipment which is able to deliver correct electric current, voltage and frequency based power to the load. Based on their functionality or functional features, the power supplies are classified into regulated, fixed and regulated adjustable power supplies. Again, we find further classification, but let us not worry about that. The further classification is a linear power supplies and a switched power supplies. Let us not break our head for that. Let us just concentrate on our today's content, that is DC regulated power supply. As you move ahead uh, further, you are going to you will be able to understand or get to know various types of power supply. But today's topic is DC regulated power supply. Let us concentrate over that. Okay. Our today's topic is DC regulated power supply. In this discussion, we are going to study these subtopics, that is need for DC regulated power supply. There we are going to understand what is the basic purpose or why we need it. Then second subheading is factors affecting regulated power supply. Sorry, unregulated power supply. That we know that we are concentrating on regulated power supply, and at the same time we should know what happens or the factors which are going to affect if the power supply is unregulated one. That we are going to discuss in factors affecting unregulated power supply. Then we'll move on to exactly understand what is DC regulated power supply, and last bit of the discussion is basic block diagram and working of the DC regulated power supply. RPS, DC RPS is an acronym for a DC regulated power supply. Okay. First we move to the need for DC regulated power supply. We know that most of the circuitries or most of the equipments, home or office equipments or domestic appliances or any electronic gadgets like toys or any video games, These are all require a DC power source for their proper functioning. When this DC power we are able to get it from various resources various sources such as we can get this DC power to be DC power that is required from the DC batteries. We can get it from the solar energies, or else we can get it from the DC regulated power supplies. Okay, let us see what happens when we go with the DC batteries. DC batteries are nothing but we have already, most of us are maybe using this the batteries which are 5 volt 12 volt batteries. So depending upon one's requirement, people go for it. So in again batteries, some of them we find rechargeable on a regular basis. The rechargeable in the sense we need to charge up on a regular basis on a certain intervals of time. When the battery gets completely discharged, we need to again recharge those batteries. And some batteries we find as a disposable batteries. Once the complete energy is being utilized, the battery becomes unusable. So we supposed to dispose those batteries. So hence, most of the times these batteries, DC batteries, are not a reliable one or advisable one for the continuous requirement of a DC power supply. So hence this battery option for DC power source is being rolled out, but in some cases we use it still, where we cannot apply or cannot make use of a wired kind of a things to those portable articles or gadgets. We depend on batteries only for to power up those circuitries. But most of the cases which require continuous kind of a DC power source supply, we cannot depend on the rechargeable or disposable batteries. The next option goes to the solar cells. Solar cells, as the name itself indicates, that it is a renewable energy. Nowadays, everyone is heading towards it because we have to have safeguard our environment and make use of the available energy in our surroundings. So solar energy is abundant in some of the places. In such places, people can go for a solar cells, but solar cells cannot be used in the absence of solar energy, and also it incurs the highest high initial costs. That means in order to set up that it requires solar panels and other circuitries, that all increases its initial cost requirement will be more in case of solar energy. Hence people use it wherever it is large amount of energy requirement and budget is also more. There people go for a solar energy. But where it is a small amount of requirement, smaller budget, and where it is a continuous supply of DC energy is required, people go for a or depend on a conventional DC regulated power supply. Conventional DC regulated power supplies are nothing but the you might have used it already or you may be using it. What we call it as our regular mobile phone chargers, laptop chargers, or any other device chargers, or we may be having stabilizers in order to supply energy to the integrated circuit setup in our for our digital TVs, television systems, or equipment. We call that box as a stabilizer box. In that also we find a DC regulated power supply. in almost all stabilizers we find a DC regulated power supply. Hope you have followed this. The need for DC regulated power is the requirement of a power source for some of the gadgets, some of the circuitries where they depend on a DC power as a source of the energy to be powered up. So hence ultimate there are a variety of options like batteries, solar cells, but the best and widely used option is conventional DC regulated power supply. Okay. Okay, next coming to the factors affecting unregulated power supply or unregulated power supplies. We have seen that we came to know that DC regulated power supply, most of the devices require it as a power source. If the DC regulated power supply becomes or if it is unregulated, DC regulated power supply means which converts input AC to the stable, constant, regulated DC is called as a DC regulated power supply. So if this power supply is not able to produce constant, stable, or we can call it as unregulated DC output, such power supplies are called as unregulated power supplies. So these unregulated power supplies sometimes get affected by various factors such as load variations, AC main supply variations, and temperature variations. Load variations in the sense any end device to which we power up the DC source is called as loads. The end device which we power up is a load, becomes the load, and by which we power up the load is called as a source to load. So when the load draws more current, then what happens if the power supply, if the DC power to be delivered from the unregulated power supply, what happens? Load is drawing more current, it is getting the DC power from the unregulated power supply, then that DC energy to be delivered gets decreases. Are you able to understand? So if the load is drawing, its specifications are normal and it has to draw regular current, but sometimes if the load is drawing more current due to some reason, what happens? The DC power source has to, irrespective of the load current increase, it has to supply the constant DC voltage, but due to some reasons, the load draws more current, the DC output to be delivered to the load should not decrease or increase. Due to increase in a load current, there would be a decrease in a DC output energy. DC energy to be supplied to the load. This is called as load variations. Hence, it's been explained as the load changes, the output gets affected due to the various drops. Why this happens? This happens due to the various drops taking place at the variable load. So, this will affect the DC power to be delivered to the load. Second point is AC main supply variations. AC main supply variations meaning all of us might have experienced or might have seen or heard many a times that due to surges or high current surges at the home, the devices or the appliances which are not being safeguarded by stabilizer or not provided with a stabilizer directly connected to the AC mains have got bursted out or got damaged or got fired up. So these are all the bad ill effects or bad effects of the AC main supply variations or fluctuations. In this AC supply main variation, basically what happens is there comes the surges or high currents which are very spurious to the circuitries or the equipments or appliances used at offices or homes, because they are all made up of integrated circuits and sophisticated electronic circuitries, and they need to supply rated ratings of the current or voltages. Due to sudden any variations in a fluctuation, that may cause a problem. Okay, now coming to the, sorry, my battery was going low, so I just went to adjust it. Don't mind. Okay, now coming to the temperature variations. Okay, I think we have not yet completed the AC main supply variations. These surges or spurious currents again in turn affects the DC output power. Hence, any increase in the AC input means increases the DC output, which again may cause the functioning of the load or damage the functioning of the or damage the load and device, because it has to be supplied with a constant voltage. Due to increase in the AC mains voltages increases the DC mains. So it should not increase, it should able to provide the fixed voltage. So again this is also should not happen, this also should not happen in DC power supply. The one which suffers this problem generally suffers in occurs in a unregulated power supply. Therefore, we should have a DC regulated power supply. The one more problem is temperature variation. As the performance of semiconductor devices is dependent on temperature, temperature variations causes the DC output variation. It means that we know that when semiconductor devices conducts, they liberate heat or a temperature. They liberate kind of energy which is in the form of a heat or a temperature. So this in turn enhances the temperature of the overall circuitry. Again, when the temperature increases, the performance of the device also slightly varies. So this again may be one of the major cause for variations in the DC output power to be delivered to the load. Okay, to conclude in a brief, DC unregulated power supply suffers from all these problems. Primarily, variations in the load current, that is when load current increases, the DC output power to be delivered to the load also gets increases. This should not happen. Then second point is AC main supply variation. If AC main supply voltage increases, it also increases the output DC voltage, which again should not happen, because it should be able to provide always a constant. It should not increase or decrease the any increase or decrease of a DC voltage at the DC regulated power supply stage should not happen. It should always to be able to deliver a constant DC voltage irrespective of all these variations, all these problems or issues that are affecting to the load. So third one major problem is temperature variations. Okay, with this we learned that these factors affects in a unregulated power supply. Therefore, we are supposed to go for a regulated power supply. Then in detail we'll see what is then a regulated power supply is, how it can improve the these problems affecting the unregulated one. Okay. Okay, now coming to the DC regulated power supply. First, we have to know that a question may arise. What is DC regulated power supply? A DC regulated power supply is a power supply which converts AC input into a constant DC. Uh, it is generally used to output ensure that the output always remains constant irrespective of any changes that we have just now discussed. Any changes in irrespective of any changes in what are those factors? Any changes in load current, any changes in input voltage fluctuations, or any changes in temperature variation of the circuit. These factors should not affect the output of the DC. It should be able to provide a constant DC output voltage to the load. Such power supply is called as a DC regulated power supply. Then moving on to some what exactly it's going to give. It is going to give clean, stable DC output voltage without any noises or any kind of variation in its output. This DC power supply is also widely known as or also called as a linear power supply. Let us not bother about what is linear and non-linear. Or in a one single sentence I can tell you, the device, it makes use of the devices whose conduction lies in a linear region. Those are called as a linear power supplies. Let not to break your head what is linear region, non-linear region. You gradually will come to know. Okay, now moving on to the working of basic block diagram of DC regulated power supply. Here you can see the block diagram. There are 5 stages, input including input stage and load. There are 5 stages. So here at the extreme left end you can see it is called as the input end. Extreme right you can see as a load end, or here it is a power source. Input side is a power source, output side is a load to which this power is to be delivered. Intermediate stage is nothing but a DC regulated power supply stage. Okay. So with the three, it shows the single phase DC regulated power supply stage block diagram. Here it consists of, at the input you can see that there is a 230 volt 50 hertz AC input supply voltage to be delivered to the load. So it is first stage to this AC supply comes the transformer. Transformer is nothing but it is a static electrical device which works on mutual induction process. The primary function of transformer is to transfer or deliver power from energy from one circuit to another circuit, or from input circuit to the output circuit. So here it is consisting of primary winding at the input and secondary winding towards the output circuitry, separated by a core. So iron core or any kind of a core, you might have studied about this working of transformer in your basics in first semester. Okay, now let us understand why we need a transformer. Transformer function is to deliver or transfer energy from input to the output circuitry. Here most of the time we require a step down transformer because our DC power requirement is generally to supply DC energy to the integrated circuitries which require only the plus 5 volt, plus or minus 5 volt, or plus or minus 12 volts. So based on our requirement, or sometimes 30 volts. So based on our requirement, we make use of a widely step down transformer in most of the DC regulated power supplies. So here first AC input is supplied to the transformer depending upon its turns ratio. Turns ratio is nothing but number of windings in the primary side to the with respect to the number of turns across the secondary winding. This ratio N1 is to N2 is called as a turns ratio. This ratio is chosen such that it always steps down the voltage for a lesser power requirement for a DC. So based on turns ratio, transformer is chosen. Transformer will not changes the uh, frequency parameter or the nature of the waveform across its secondary, but it simply reduces in its magnitude. So amount of voltage is reduced, but frequency and the shape of the waveform remains same across the output of the transformer. So here this we can see that in a very clearly in a diagram. So input to the transformer is little maximum amplitude, peak to peak Vm to minus Vm, instantaneously varying, which is sinusoidal in nature. Hence it is a Vm sin omega t waveform. So same is coupled to the output of the transformer. The amplitude is reduced based on the turns, number of turns, and we can see the output of transformer has retained the shape of the input wave, that is AC input wave, and but only the magnitude is reduced. It means amplitude is reduced. So this AC input we are supposed to convert to the DC, pure DC output with the intermediate stages called rectifier, smoothing and regulator circuitries. Okay, next stage to the this reduced amplitude sinusoidal waveform transformer output is coupled to the or applied to the rectifier input. Rectifier is a device which converts, it is the primary device, it is the main device or heart of the device for which it is called as a DC power supply, because it is the only device which is able to convert the AC energy into DC. Because of this name, we are going to call this power supply as a DC power supply. So, what is rectifier? Rectifier is going to convert AC input energy into DC output. So, sinusoidal waveform into pulsating or a rectified output. So there are various types of rectifiers such as single diode based half wave rectifier, and again we find full wave rectifier. In full wave rectifier we find again two types, the center tap full wave rectifier and a bridge type full wave rectifier. So the output of rectifier we can see here, its function is to convert AC input to DC. So it is going to produce a pulsating DC as shown in the waveform after the rectifier output. So it is not a pure DC. We are supposed to get the last waveform like pure, which we call it as a pure DC. But here still it is not a pure DC. It is a pulsating DC. Pulsating DC in the sense it is having a large amount of AC component present in the output of the rectifier output. So this is oscillating, it is kind of oscillations. So hence we call it as a pulsating DC. It is DC. All the pulses are we can find only in towards one side. It is not like a AC. All the positive and negative cycles are going to be converted to the positive side only. Hence, but still that continuation variation is there, no? It is in a pulse nature, no? We call that as a pulsating or AC component present across the output of a rectifier. So as it is not a pure DC, we can call it as a unregulated DC output. So this, as it is, we cannot use for the DC power to supply the to energize the load. So we need to suppose to remove the AC component. In order to filter out or remove the AC component, we next passing it through the filter circuit or a smoothing circuit. So smoothing circuit, as the name itself indicates, filter. So it is able to remove the certain amount of AC component present in it. So therefore, output of filter we can see major amount of AC component is being filtered out. Only little of the AC component is left out across the output of the smoothing circuit. This filter circuit, there are a variety of filter circuits available. So widely passive storage components are used as a filter circuit because we need to store energy and discharge it to the load. So generally capacitor kind of a filter or a inductive kind of a filter or combination of both capacitor and filters are used depending upon the rate of filtering and depending upon the type of the design. It all depends on so many parameters. So based on that they are used. So function of filter circuit is to filter out the AC component present at the rectifier output to the maximum extent. But still the output of filter we cannot say it as a stable, fixed, regulated DC output because it is still composed of or consisting of little amount of AC components in it. So therefore, this AC component to be filtered out by after passing through the voltage regulator stage. Voltage regulator, as the name itself indicates, it regulating the any variations in the input voltage and producing the constant or a fixed DC voltage. There are many types of voltage regulators such as a fixed and a variable or adjustable voltage regulators in the form of integrated circuits like 78XX series and 79XX series. LM317 is called as a variable or adjustable voltage regulator. This all you are going to study in a further sessions, coming sessions. But time being, you just know the primary function of voltage regulator is irrespective of any variations in the load current or input voltage variations to supply a constant pure DC output to the load. So that function is done by the voltage regulator circuit. Hence, after voltage regulator circuit, we are able to find a clean, pure, stable, fixed DC output. Hope you are able to understand or follow each stage of the functioning of the each stage in the overall block diagram of a DC regulated power supply. And with this, I will just brief recap of working of this I will explain. AC input is the AC 230 volt 50 hertz AC main supply is applied to the input of the transformer. Input of the transformer will just steps down the AC input to the desired level to be delivered to the load. So then the AC output, transformer output is again a sinusoidal in nature like a AC input, which is to be converted to the DC by the main device called as a rectifier, for which the circuit is called as a DC regulated power supply, is a rectifier which converts, whose primary function is to convert AC to DC. But the rectifier output is not a pure DC, it is a pulsating DC because it is consisting of a major amount of AC component present in it, which is then supplied to the filter or smoothing circuit to filter out the maximum amount of AC component, which are called as widely called as a ripples. Sorry, I forgot to highlight that. This ripple, the AC component present in rectifier output are widely called as a ripples. They are known as a ripples in DC regulated power supply terminologies. So hence uh, it should not have high ripples. It should reduce the ripples, or it should have almost zero ripples across the output of a regulator. So smoothing circuit is the pulsating output is passed through the filter circuit or smoothing circuit, which are going to reduce the, not completely it's going to remove the ripples, it is going to remove the ripples to the negligible amount, but yet it is, we cannot call this output as a pure DC, we call still it as a unregulated DC output, which is not safe to supply to any device because it may damage the device. We have seen the factors affecting the unregulated power supply. The same problems occurs due to the unregulated one. So hence we are supposed to pass it through the voltage regulator circuit in order to get the pure, clean, constant, fixed, regulated DC output, which is now safe to drive or power up any devices which require DC as a power source. Okay, this is the complete functioning of a block diagram of a DC regulated power supply. Hope you have followed it well. Okay, this ends here. We are going to end our discussion of DC regulated power supply. Let us move on to some sample questions, multiple choice questions on the today's discussion. Okay, let us know how much you have followed it. Okay, the first question, sample question here is the output of voltage of an unregulated power supply is affected by the factors. So unregulated power supply, we have seen there are various factors, whether it is affected by only the input voltage or only by the load current or only by the temperature or all of the above. The answer is D, all of the above. Okay, the next question is the rectifier circuit converts. You have to remember this. I have repeated while explaining that rectifier is the primary device which, because of which we call that power supply as a DC power supply. Yes, come on, answer the question. It is AC to DC. It converts AC to DC. Hence the answer is C for this. Okay, this question, in an unregulated power supply, if load current increases, the output voltage decreases or increases. When load draws more current, the DC power to be delivered to that load increases or decreases. If the load draws more current than its rating, from the power source it is drawing the current. When it is drawing more current than the rating, then definitely it decreases the DC output voltage. Hence the answer is B. In an unregulated power supply, if an input AC voltage increases, the output voltage increases or decreases or remains same or none of the above. It means the question have followed. Question is that in an unregulated power supply, if there is any AC input fluctuation, if voltage rises, if input voltage increases, then definitely the DC output voltage also gets increases. Hence the answer is A. The last question of the discussion is the output of a rectifier is it a 60 Hz AC or a smooth DC or a pulsating DC or is the 120 Hz AC? Okay, come on. What is the rectifier circuit we have discussed? Rectifier is nothing but a circuit or device which converts AC to DC. So therefore the answer is, what kind of a DC it is going to produce, smooth or pulsating? It is a pulsating DC. Therefore the answer is C for this. Okay, with this we are going to end. Okay, thank you for listening to the lecture. Thank you so much. This is my team coordinated. Thank you.